Good morning, students. Today we will be starting with a new chapter, that is chapter 1, solid states. We have studied in our earlier classes solids, about properties of solid, that solids are having substances having definite shape, size and volume, or we can say solids are hard because they are having strong intermolecular forces in between them. But if I talk about this sponge, you can see this sponge. This is not hard, but we know that this is solid. Similarly, if I talk about this paper, this is also solid, but this is not having any definite shape. So this is my topic today. What type of solid this paper, this sponge is. Two types of solids are there. First is crystalline solid and other is amorphous solid. The solid you have studied in earlier classes, which we talk about, is crystalline solid. Crystalline solids are those solids in which constituent particles are arranged in definite order. Means, suppose if the solid is made up of two particles A and B, then the definite ordered arrangement means if A is followed by B, then again A, then B. This type of arrangement will be found throughout the crystal. But amorphous solids are those solids in which constituent particles are irregularly arranged. Since, see here, if A is followed by B, then again A, then again A, then B, that means we cannot predict the ordered or arrangement how the particles are arranged in a solid. That type of solid is called as amorphous solid. I again repeat, crystalline solids are those solids in which constituent particles are regularly arranged such that these solids have regular or definite geometry. These geometries we will be studying further in this chapter. While amorphous solids are solids in which particles are irregularly arranged. Therefore, these solids do not have any definite order. These solids follow long range order. Long range order means that definite arrangement of constituent particles are found over a long distance. While this solid follows short range order, means suppose if it's A, B, A, then the order disturbs again and then again it can be regular and then again irregular. This type of order is known as short range order. These solids are true solid. True solid means that I told you earlier also, the solids you have studied earlier is crystalline solid. Means the properties of solid, all the properties of solid will be followed by these crystalline solids. That is why these solids are called as true solids. But the amorphous solids are pseudo solid. Pseudo solid means they will not follow all the properties of solid. Like I showed you this sponge. It is not having definite shape. Why? Because it is an amorphous solid. Similarly, this paper also comes under amorphous solid. Means amorphous solids, they will not follow all the properties of solids. Also, these solids have tendency to flow slowly. Therefore, these solids are also called supercooled liquids. Next point is this crystalline solid show sharp melting point. Sharp melting point means, suppose if I am saying that melting point of NaCl is 200 Kelvin, then at 199 it will remain solid, and as soon as temperature reaches 200 it will melt completely. That means you can tell me that ma'am NaCl melts at 200. This means NaCl is having sharp melting point, means one particular temperature at which this solid will melt. But if I ask you about polythene, if I give you polythene and ask about melting point of polythene, what you will say? Ma'am, polythene will start melting at 20 and then it melts till 30. Means you will be giving me a range of temperature. So amorphous solids melts over a range of temperature. Next point is crystalline solids are anisotropic in nature. Anisotropic means some physical properties like refractive index, resistance show different values when measured through different direction. But the amorphous solids are isotropic in nature. Isotropic means just opposite. Physical properties will show same values when measured in different direction. All metals, all ionic solid are crystalline solid, while all polymers, quartz glass is an amorphous solid. Here is one question. If you see, I have written quartz in crystalline solid. You remember quartz is SiO2, silica and oxygen are arranged three-dimensionally. While from quartz we make quartz glass. The window glasses are known as quartz glass. That is an amorphous solid. How? Actually, how we prepared quartz glass from quartz is, first we heat the quartz and then we immediately cool it. On cooling, the quartz will solidify and what will form is quartz glass. This process is known as quenching, heating and then immediate cooling. Because of immediate cooling, silicon and oxygen particles are not getting sufficient time to arrange. That is why quartz glass is an amorphous solid. Also, because glass is an amorphous solid, one more question is there. We have found that window panes of old glass buildings are thick at the bottom. Why? Because quartz is an amorphous solid, and I told you earlier also these solids have tendency to flow. Glass will flow slowly and accumulate at the bottom of old glass building. Very slowly it flows. That is why window panes of old glass buildings are thick at the bottom. Also the windows of old building, glasses of old buildings turn milky. Why? Because on day there is heating while at night there is cooling. This process of heating during day and cooling during night is known as annealing, and because of annealing, glass property of glass changes. That is, it changes from amorphous to crystalline. Therefore, the glass acquires crystalline character and it turns milky. Thank you.